now that you've had a little bit of practice with just the Pythagorean theorem with just numbers, we're going to talk about a little bit further application to the Pythagorean theorem. Now, before we talk about the application, let's do a little review. So again, Pythagorean theorem can be used for a variety of purposes as long as you're able to create a right angle between two sides. Now, if you're solving for the hypotenuse of a right triangle, you can use this formula: a squared plus b squared equals c squared, where a and b are the legs, aka the shorter sides, and c is the hypotenuse, aka the longest side. So in this case, now, unfortunately, I did not actually put it in, but I will do it right here. That is our right angle. So that's 90 degrees. Quick identification. Our hypotenuse is always the one that is across from the right angle. Let's just put an H for that. Of course, if you write HYP, that works really great too. Kind of make sure that you don't kind of treat it as a variable, even though this one really does. Works out really nice. Anyways, if we use our Pythagorean theorem, our a squared plus b squared equals c squared, it doesn't matter what we call a and b. I can call a 17 and b 15. I can do it the exact opposite way. Of course, my c is my unknown. In this case, I have it labeled as x. So I'm going to use x. If you want to use smiley face, you want to use star, whatever you want to use, just make sure you use it consistently and you use it correctly. Now, 17 squared should be 289. Let me just use my calculator to double check. Pretty good. But sometimes my math does go wrong. 15 squared, I can do that one in my sleep. It's 225. And that would equal our unknown squared. So I'm using x, but you can use whatever you need to. Now, the only thing that we can do here is we can actually combine our 289 and 225 to give us 514. Now that would equal x squared. Now, no matter what, that 514, just as I've explained before, is the area of the square that is built off of that side. So the entire area of that square would be 514. We don't want the area. We want to know the side length. So we have to use the fact that the connection between finding that side length and our area is by taking the square root. Now, technically, we do need to take both sides. So that this way, we're only left with side length. If we square root a square, we're left with just side length, which is this, in this case, is x. And if we take the square root of that, we get 22.67. Now let's just practice our rounding. 6715680975097. It's actually more decimal places than most of your calculators will have, just because of the calculator that I'm using right now. So if I ask to the nearest tenth, I'm asking about to the nearest one decimal place. I need to look at my second decimal place. If it's 5 or higher, that's going to bump this up. If it's 4 or lower, it's going to stay the same. But since 7 is definitely bigger than 5, well, it's 2 bigger than 5. If I round to the nearest tenth, this would be 22.7. And in this case, we don't have any units, so we don't really need to. If you do include a unit, you can actually use the unit U, which literally just stands for units, whatever it is. Now, if we're solving for the leg of a right triangle, we need to manipulate the formula, which means if we want to try and solve for whatever b squared is, what we need to do is we need to subtract the a squared. Of course, if we are solving for the a squared, we just subtract the b squared. So the equation would just turn into this. B squared would equal whatever our c squared is, subtracting the a squared. If you write this, now I give you the formula. Yes, you should know exactly what it is, but I'm going to still give you the formula. If you, at the very beginning, you can't remember how to do this, you just memorize this and write it down on your test, that's absolutely fine. But knowing how to manipulate an equation is going to be one of our bread and butters, and we'll be talking about lots of manipulating equations later. So now let's talk about solving for x. And once again, I really do need to put this right angle in here. Identifying where that hypotenuse is probably going to be your saving grace. That's our hypotenuse. Our hypotenuse is always c. It doesn't matter the other two sides. And if you can notice in any of our examples, our a and b are always the ones that are directly attached to that 90 degree. So you have to be careful. You have to look at your triangle. You can't just automatically go a squared plus b squared equals c squared. You can't just go 15 squared plus 17 squared. No, you have to look at your triangle. You have to look at the picture. If you're not looking at the picture, you're not doing the math right. It's the same thing as if you're going to be reading a book. If you're just looking at the words and you're not actually reading them, you're not getting any kind of benefit from it. If you're playing a game, if you're just looking at a ball, if you're looking at the floor, let's equate it more like that. If you're playing a game of basketball and you're just looking at the floor, you're missing the entire game. So pay attention. You have to pay attention to the triangle. And in this one, yeah, our c value is 17. So if we use our Pythagorean theorem, a squared plus b squared equals c squared. We're going to show you the other way too. But our c is 17. So I'm going to put that 17 right in there. My b squared, in this case, is my x. And 15 squared is my a. Now there's multiple ways of doing it. Personally, I like doing it this way. 15 squared is 225. X squared equals 17 squared is 289. I do my squaring first, as it actually does directly tie into our order of operations, which we're going to actually talk about even further in our next unit. We're doing that exponent first. We're doing the exponent before we do any addition or subtraction. Goodness. You never get rid of it. Anyways, we subtract that 225. And all we're left with is that x squared would equal, should be 64 if I'm doing everything correctly. Yeah, 64. And once again, that is the area of the square that is built off of this side. So if 64 is the area, we need to know what the side length is. Well, that means we're taking the square root. So x would be 8 units. So this is a 15, 8, 17 triangle. Now if we use this equation, all that it changes is that our b squared, in this case, is x. So if we change it, and it's just x squared equals our c squared, which we've already identified as being 17, subtracting our a squared, which is 15 squared. 17 squared is 289. 15 squared is 225. X squared would equal 64. Take the square root. And x equals 8 units. Well, really, it's not any extra work because really, this is our equation. We just didn't write the equation up here. we still have this step that is pretty equivalent. This step, which is equivalent, we get to here. So either way, you're getting through the exact same amount of work, and it's the exact, and you're still getting the exact same answer. So again, I cannot stress enough that you need to look at the triangle. You need to see where is your hypotenuse. The other two sides, yeah, we don't really, they can be interchanged. But your hypotenuse is extremely important. And as you go into grade 10, you're going to be using that hypotenuse a lot. You're going to have to know where is the hypotenuse. You're also going to actually have to be able to identify these two sides in relation to angles, but that's a tricky equation for later. Okay. Now, this is nothing new. This is the exact same stuff as what we had just done before. But let's look at the title. Applications. Applications means word problems. Now, just a little tidbit of information is the Pythagorean theorem is used for many applications. In pre-calculus 20 and foundations 20, though, we actually go past the right angles. We'll actually use more other formulas for non-right triangles. But we don't have to really worry about them now. I do like talking about them just because it's a lot of fun. Here's the beginning of a pre-calculus 20 or foundations 20 equation. It's also done in workplace 30. Sorry, that's one thing that I definitely do need to put in here, is that it's also, this is also an equation in workplace 30. Now, the Pythagorean theorem is going to be used in pretty much every single equation or every single course that you're going to be doing for the rest of your high school career. But where this changes in the pre-calculus 20, foundation 20, and workplace 20, sorry, not workplace 20, workplace 30, is that it adds in the stipulation that what about if we don't actually have a right triangle? It adds in a little bit of an extra tidbit to adjust for non-right triangles. Now again, this is not what you're going to be talking about. This is all that you're going to need. This is grade 9. It's also grade 10. It's all you're going to need. You're not going to need to know that part yet. Yes, you're going to need to know. You're going to have to learn in grade 10, what does cosine C mean? Cos C. We'll talk about that in grade 10. We won't have to worry about it right now. A squared plus B squared equals C squared. Or C squared equals A squared plus B squared. All right. A ladder, 5.2 meters long, leans against a vertical wall of a house. The bottom of the ladder rests, sorry, that's a typo, rests on level ground and is 1.6 meters from the wall. How high up the wall does the ladder reach? We're going to round to 2 decimal places. So let's talk about the situation. We have a ladder leaning against the vertical wall of a house. So if we have a house, let's draw a house. We have a house, we have the roof, we have the door, we have some windows, and then we have a ladder. Hopefully no one steps on this ladder because there's definitely would not be up to code. Now, obviously we have some ground here. Yes, in my world, grass is purple. If I'd been smart about it, I would have made my grass green and my ladder purple, or really aluminum, probably a little bit nicer. Anyways, let's see what parts of this we're making. We have a 5.2 meter ladder and leans against the vertical wall. The bottom of the ladder rests 1.6 meters away from the wall. How high up the wall does the ladder reach? So we have a ladder which is 5.2 meters long. The bottom of the ladder is 1.6 meters away from the wall, so that's our 1.6. We're trying to find out how high up the wall is this. Now we do have a right angled triangle right here. So here's a situation, but I'm going to make this graph look a little bit nicer. we're trying to find out that. We know that the ladder is 5.2 meters. It's 1.6 meters away from the wall. If this is our right angle, let's show the equation. Now, again, pay attention. 5.2 is across from that right angle, which means that that is our hypotenuse. That is our C. You have to put that in as C. It doesn't matter for A and B. So I'm going to actually go a little bit different. I'm going to say A squared plus B squared equals C squared. That's pretty common. Our C is still 5.2. And it's squared. I'm going to call this B. Actually, sorry, I'm just going to make that red. 1.6 squared. And our x squared is right there. So when I type some stuff into my quick calculator, I'm going to get a few fancy things. For example, x squared plus 1.6 squared being 2.56 and 5.2 squared being 27.04. To get this x squared by itself, subtract the 2.56. Meaning I'm left with x squared being 24.48. But as I've explained before, that's not a side length. It would make no sense for that to be 24.48. Not when that's 5.2, which is our hypotenuse, should always be the longest side. Let's treat it like before. If we built a square off of this side, this is the area. To find the side length, we take the square root. We take the square root of 24.48. We get 4.9477267507411193. Again, my calculator goes a little more decimal places. But I want 2 decimal places. So to round to 2 decimal places, I need to look at the third. I need to look at this third decimal place. If this is 5 or higher, it's going to round it up. And it absolutely is. So that 7 is going to round the 4 up. So it's going to be 4.95. And in this case, we're measuring this in meters. So we're going to use meters. And I'll tell you when I want sentences. This one, we're going to write it. The ladder reaches 4.95 meters up the wall. Okay. How high up that wall does the ladder reach? The ladder reaches 4.95 meters up the wall. Using the question in my statement. All right, let's do these two relatively quickly. A door frame has dimensions of 32 inches wide by 80 inches tall. Pretty standard door. If you're trying to carry something fragile through the door frame that cannot be turned straight on its side, what's the maximum height that your object can be? So if you have a doorway, and 32 inches by 80 inches. Yes, know how I've used 2 different things? Only reason I'm writing is, yes, IN stands for inches. 2 tick marks also stand for inches. Only reason I'm doing it, just to kind of fun fact, I guess. If you're trying to carry something, obviously, you have it 32 inches. It could also be 80 inches, but we want to know what the maximum height of the object would be. The maximum height is always determined. Yeah, where's my thing? There it is. And if you turn it on its side, turn it just diagonally. Yeah, don't know what it could be, but obviously it's something that we want to find that for. Hopefully, most door frames are installed at a nice 90-degree angle. So let's see what we have here. In relation to that 90-degree angle, that's my hypotenuse. That's my C. So if we have our a squared plus b squared equaling c squared, our a and b is set up perfectly. You don't have to do any further manipulation. We just got to do this. 32 squared plus 80 squared. If you're using 112 as an answer, you are going to get it wrong. It's a squared plus b squared equaling c squared. And by using my calculator, 32 squared, so 1,024. 80 squared should be 6,400. We add them together, so that would equal c squared. Add them together, you obviously get 7,424. That would equal c squared. But I don't want c squared. I don't want the area of a square that's built off of that side. Yes, that looks like a very bad trapezoid. Imagine it is a square. I need to find out the square root, because square root is side length of a square. See? The 86.16263691415206. The other question said how to round. This one doesn't. I'll ask for 2 decimal places again. So all we need is a third. It doesn't matter that the next digit here is 6. I only care about this. Is this 2 or high? Is this 5 or higher? No. The number 2 is definitely not 5 or higher, which means to 2 decimal places, maybe 86.16 inches. So if we write it as a statement, the maximum height of an object being carried through the doorway is 86.16 inches. Yes, abbreviation. If you write it out entirely as inches, that's fine too. Okay. Last, final example. A hiker leaves camp and walks 3 kilometers north, 2 kilometers west, 1 kilometer north, and 4 kilometers west. How far will the hiker be from the camp? So let's talk about, there's the camp. If you walk 3 kilometers north, well, let's first talk about actual orientation on a map. Never eat shredded wheat. North, east, southwest. Typically, the orientation on a piece of paper is you put your north to the top of your paper. Your east is to your right, your south is down or to the very bottom of your page, and west is to your left. So if we're going to draw this, 3 kilometers north means we're going to go up. We're going to make it 3 kilometers. Then we go 2 kilometers west. That would be 2 kilometers. 1 kilometer north. And that 1 kilometer north is there. And then 4 kilometers west. So let's make that a nice big one. There's 4 kilometers. Now, obviously, it doesn't have to be perfect, but it does have to be something that's readable. The beautiful thing about this entire triangle here is, well, that it actually does make a triangle. Sorry, I kind of spoiled it for you. We have a beautiful right-angled triangle right here. Sorry, I'm going to fix that one. So how big is all that? Well, let's do some nice simple addition. Going north, this little part of it's 3, then we went west 2, then north 1, then west 4. The entire height here is 3 plus 1. Which means this entire length there would be 4 kilometers. The entire west direction would be comprised of this part and this part, 4 and 2, which sets it up as 6 kilometers. Now, by cardinal directions, north and west are directly at a 90-degree angle to each other, especially for short distances such as this. Of course, we do deal with curves and all that kind of idea with global positioning. But for something like this, you can't notice enough of a curve. There's our right angle. So we do have a right angle triangle. I'm just going to redraw that. Four kilometers by 6 kilometers. It's a 90-degree angle right there. Well, there's our Pythagorean theorem. A squared plus b squared equals c squared. Where is our c? Across from that right angle. So that's our unknown. So I'm going to put that in. Make this nice and fast. 6 squared plus 4 squared equals x squared. 36 plus 16 is x squared. We're dealing with 52, being the area of a square built off of that side. So therefore, we need to know the side length, which means we need to know the square root. X would be 7.21. Let's round to 2 decimal places for this one. We look at the third. Don't even care that the next number is 1. Does 1 round a 1 up? No. So we'll just stay at 7.21. Our unit is kilometers. How far will the hiker be from camp? The hiker will be 7.21 kilometers from camp. Of course, that can be taken further. For example, talk about speeds of travel and all that jazz. But this one, we just need to know from the camp. Here's our hiker. He'll be 7.21 kilometers away. And we're done. Have fun. Have some fun.